Welcome back everyone. This is Just Blazor Programming and today I have a new video on lifecycle components. But this isn't just any one-off video, this is a series of videos that I like to call Blazor Advanced. Now these are just like my Blazor Basic series, and in case you haven't seen that, please look at it right here. And you will understand that this is just another continuation of that series, except that once you have gone through the Blazor Basic series, you'll be better at understanding the Blazor Advanced stuff, obviously. So today we're going to be discussing lifecycle components. So lifecycle components are something that I discussed already in a different video. I believe it was the Blazor Interview series. No one really liked it though, but in case you want to see a high-level overview of lifecycle components, or the lifecycle methods within components, I encourage you to go watch it here. And then come back to this one, because in this video we're going to be going over the actual programming of it. We're going to get our hands dirty with this as an example, so you can see them actually interact within a component. So I have a series of examples I want to show you on my IDE, and we're going to go into that, and I'll explain everything that's happening and going on there. So if you do not understand how lifecycle components work, a high-level perspective, don't worry. We're going to be going over it from a programming perspective, which I think is a lot more helpful to conceptualizing what's happening here. So let's get started. Welcome everybody, this is the project I was speaking of. So in here we're going to be going over the component lifecycle. Now I know that you see that there is already a lot of stuff written here, but don't worry, we're going to be going over this in order. And I believe that for this kind of explanation of this project, you don't really need to code what I code. This is more of an understanding how the lifecycle components interact within a Razor component. So in this case, my actual code here is not really that important. It's just to help trigger the rendering and just for you to actually see the rendering happen. So what you really need to understand is just how the lifecycle methods work and how and when they are called. So everything that I code in here is just to ensure that I invoke them. So just keep that in mind when you look at this. So don't get too crazy when it comes to my code here. So I'm going to explain to you what exactly is going to happen in this first example. You don't have to worry about these for now. I'm just going to leave them here just to have. And in this case, the way I'm going to show you the actual order of lifecycle methods is by having a string, a list of string that will have a for each loop here that when the component renders, it will loop through and it will just spit out all the strings that are within it. So what is going to go into that list is basically on every method that gets called by the component, it'll put them within the string and the list of string in order. So when OnInitialize gets called, we'll have an OnInitialize string in there. Then the async version of that goes in there. Then the parameter set, then the parameter set async. It's a very, very simple example here to show you the order between OnInitialize and OnParameterSet, because in a component, the OnInitialize gets called first, and then the OnParameterSet gets called after. So you're gonna see that right now once I run this. And don't worry, I will go over what every component, what every lifecycle method is supposed to do, and how they affect the components. So as you can see, the OnInitialize gets called first, and then the OnParameterSet. So what's happening here is that this is basically setting up parameter values that get passed into the component from the parent. Now I have an example of this that you can see much easier than what we're doing here through something called a nested component, something I'll go over in a different video because I believe it is also another advanced topic. But in this case, we're just going to be using this in order to show the OnParameterSet and how that works. OnInitialize is very simple to understand. As you can see, I have a value here called time equals 1. And just to show you that it works, I'm just going to add it here to the code. So at the moment that we run this, this will already be set up. Because I'm in the OnInitialize sync. In the OnInitialize, I'm already setting up the time equals 1. If I go down here, you see that before this gets called, this was already called and this was already set to 1. And I can set it to whatever I want here. And the way you would use this effectively is if you have data coming in. So let's say you want to do a database call, you will want to set up your most usually the asynchronous method here. Call the database, wait for the data, and then data will populate whatever properties you have going on. That's what's happening here, and that's what I'm trying to simulate. That's why I'm not going to go over OnInitialize too much because it's really that simple. OnParameterSet is a little bit different, and there was no example for me to show you here. So instead, to show you how OnParameterSet works, I had to create a component. Now, this component actually already existed in, if you went through my Blazor Basics project and you found the routing video, that video, I created a component there, a very, very simple one just to show how the routing works. And we're going to be using that very same component to do this. Now, does that mean you have to go over that video in order to understand this? No. This is just because it was available to me already, and I just needed a component with a parameter in it. It doesn't matter what it is. All I need to do is have a parameter in it for me to show you what's going on. So this is the component that I am passing this parameter to. This is the, again, this is the route thing. This is not important. In fact, none of this is really that important except having a parameter here. This is what's actually important. So what I am doing in this case is passing in an ID. It doesn't matter what the ID is, but it's passing in as a parameter. And I'm doing the exact same thing in this component. This is, again, a component. So all components have these lifecycle methods running. So in this case, I have the OnParameterSet here also running, just like I did in the other component, and with another list of order events. So you'll also see this get triggered. So you're going to see how the onParameters will get triggered here. So the way I'm triggering this is by having this is a calculator basically that I created here on the fly. All it does is add two numbers together. So what this will do is that it will keep changing that value I'm passing in all the time, every time I press the add button. That's all it's really going to do. And because of that, it will change the parameter, and then that will proc the onParameterSet, which you can see. So again, this is not that important. You can do this in any other way. You could have just the add button, just have random values in there if you feel like it. This is just because I'm going to use this example a little bit later, but this is how I'm controlling the parameters right now. As long as the parameters change, that's what is most important. So as you can see, the onParameterSet also gets called here, just like here. And now we're going to do the same thing. 2, 1. So this is going to be 2 plus 1. I'm going to add that. And it equals 3. 3 gets passed into the parameters of the component, and you'll see it pop up here. So because the parameter didn't change, this does not get called. So I'm procking this as much as I want, but this will not get called here because, again, the parameter changed. But the moment that I change it to change the parameter, it will activate again. That's what that is used for. This is a very simple way of looking at it. So that's how the onParameterSet works, and that's what it does. So the next thing we're going to be working on is the AfterRender one. That will be OnAfterRender here. So there's going to be a bit of, so the reason why I call this advanced Blazor is because you're going to see something very weird with this behavior, at least very weird to us. So what's expected is that when we call upon, these render, these lifecycle methods, we'll see OnInitialize get called first, and OnParameterSet, then the OnAfterRender. So what you would see is that the OnAfterRender should not even show you what's happening here because of this being rendered first. That is the for each loop here. This would be rendered, and then OnAfterRender gets called after the fact, so you wouldn't be able to see the OnAfterRender get put in. But components are not so simple, and there's some complexities when it comes to the component lifecycle, which I'm going to show you now since I ran into trying to do this tutorial. I'm running this right now. Let's go to lifecycle here. So go to OnInitialize. Okay, that's what we expected. Then it hits the first render OnAfterRender, and then OnParameterSet, then the AfterRender parameter one. So this doesn't look right, correct? So just take it from me in my research of looking as to what's happening here. This particular lifecycle method is a bit more complex than it first seems, at least when it comes to the interactions with the other lifecycle methods, because there might be other things rendering that you don't understand it are rendering right now. So I've tried it, even with removing this calculator and removing this component up here. As you can see, this also has about the same issue. It comes to the render thing when it's like rendering here, but yet the OnParameterSet gets called right afterwards. That is not what's going on here. So in order to show you what is happening, I put breakpoints here. So let me see if I could proc this. So what you don't see me doing is I change this, and then this should proc something here. So OnAfterRender gets called after doing this, and parameter set gets called here. Then the OnAfterRender gets called. Okay, there we go. Now there we go. So how parameters get called, then it gets rendered after the fact. So what all this means is that it depends on what's on your component and how your component's being handled on the page. Sometimes you run into a situation where the OnAfterRender will get called out of order because there's rendering going on, especially if you're working with these asynchronous methods, that another OnAfterRender gets procced after the asynchronous gets procced. So it's kind of strange in that way. And that will happen sometimes. Sometimes you get a clean order of things to happen, and sometimes because the components get more and more complex, there's gonna be renderings happening here and there out of order. But what you can usually guarantee is that the OnInitialize gets performed, and then the OnAfterRender gets performed last. The parameter set gets performed only when there's a parameter set to be changed, although that is also sometimes not true. It depends again on the render. So after running through this myself and running into this problem, doing some more research, this might actually happen to you where you might think that you're rendering something at the end, but actually you're rendering something in the middle somewhere, and this is just not capturing it. So just keep that in mind when you work with components, that although your rule of thumb is to follow the order that I've set up before, which is the OnInitialize parameter set, then after render, follow that order, you'll usually be fine. Because what you want to do is on the OnAfterRender is if you have, let's say, a JavaScript library you want to attach to all this to give it the styles or whatever, that is what will guarantee that it is already been rendered so that it'll be on screen. So even when this happens, you'll still have access to those HTML objects. So although in this case it wasn't a very clean example, this is actually a very real world thing that could happen to you. So in a weird way, it is good to see this, because in a lot of tutorials they'll show you, this, oh, it cleanly does everything here, 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 but that is just not the case. So it's not that they're wrong; it's that they were able to not run into the situation I ran into, which is just trying to run a very simple uh, order of strings. So, and then I did more research on it, and I found out that yes, this problem, and it's not a problem, but this is just something that you can't really see will happen. That is the issue with OnAfterRender. But we still have a few more events to go through. So in this case, we're going to be working with this timer here. So let's see. So what does this timer do? I have another lifecycle method here called StateHasChanged. So StateHasChanged is used if you need to re-render a component again. So you saw that when I ran the calculator piece here, that this gets re-rendered depending on what I add. Actually, I'm going to get rid of these breakpoints. I'll leave that one there. So in this case, yeah. So we re-rendered this again. So that's how that works here. But sometimes you run into a situation where you're not the one that can invoke it. There's information coming into view that you're expecting that you want to re-render the on it after a certain amount of information comes back to you. So let's say if you have, let's say, a timer that you're not doing an active input, but there is a change in the data all the time, or if there is some sort of like active user count that you're constantly updating, you need a way of re-rendering the component without you actually telling it to re-render. So in that case, that's what this is doing. This is checking for the state that has changed. In order for us to look at this example, I created a timer object. So all this does is that it will count up to 10 basically, and then you will be able to see it on screen. And once it does that, it will change the number of the timer that's set up. So the timer right now is going to be set to 1 where I initialized it. Now, I could have probably made it, every second to change it, but because I'm running other examples here, I didn't want to overdo it too much. So that's fine. So what we're going to do is that we have a button called start timer, and that will start the timer here. This creates a timer object, which will call on this function that does what I wanted to do, that I only wanted to change the state once every like 10 ticks basically. And then what's happening in the background is that the number is going to be constantly changing, but you're not going to see it until we reach the threshold of the 10 of the 10 ticks that I want to reach. So that's how you know that this is working, because you have a number that's constantly being changed, but it's not constantly updating, because that's how it works for these components. That's why you need this StateHasChanged lifecycle method. So I'm just going to rerun this again. We should have the timer here. All right, here's the timer. Probably get rid of this as well. I'll get rid of it now. So I've started the timer. Give it a second. Here it is. So it's going to invoke the StateHasChanged, and once it does that, it should continue. It will change it. So that's only because I stopped it in the middle there. There we go. And now it changed the timer again. So I'm going to rerun it again so we could get a cleaner version of this. Our timer. That's just to show you that the timer is actually, going off in the background, but now we don't really need that. This number will change to 10, yeah. And it should change to 20 10 seconds from now. And that's how you invoke a StateHasChanged without me trying to invoke it manually. And that's if you have something like this going on. So that's how you would handle cases where you have no inputs from the user, but you need to continuously update the component. And finally, the final thing that we should look at is this ShouldRender. So I kept this from running, because once you have this activated, I'm overriding every method with it. In case you don't know what's happening, why I have everything as protected override, whatever, because I am basically overriding methods that already exist in the components to do something for me when they get called upon their whatever case that whatever parameters that they have to run in the component. So in this case, is a ShouldRender. So this ShouldRender happens whenever the whenever this gets rendered. So basically, if I run this, it's gonna interfere with this basically. So what I'm gonna do is I'm gonna get rid of the timer object up there, and I'm gonna get rid of the component one so we could just look at the calculator. So the whole point of the calculator is just to invoke an input, but in this case, we're gonna look at the rendering of what happens. So the way you would use ShouldRender in a real use case scenario is for optimization. Let's say that you are rendering a bunch of stuff at once, and then your user decides to submit something or does a user input, but the output will be the same as what you already have on screen. There's no point in re-rendering it all and causing the page to slow down, or they're just re-rendering all the objects there. So you could put a stop to that, and that's what the calculator is going to do. A calculator will see whether or not the value that I put in there has changed, basically. So whatever if the previous value is the same thing as the value that I've just added, it's not going to re-render. This will stop the re-rendering process. So we're going to put that here. We're going to put that here. So you're gonna see exactly what's going on. But if I would decide to do a different value and add that into it, it will render. So right now it's rendering because I set up a value in there to be, it's just a normal value. So right now it's 0, right? Let's add those two together. The previous value was 0, and my new added value was 0. So it's not gonna re-render anything. So nothing changes here. If I do this instead, oh, well, I should tell you that now every time you do an input change, it also re-renders things. But in this case, this will change now with 2. Now, if you want to see this happening a little bit more clearer, I'm going to do the reverse instead. Oh, dude. So before, I was only changing the value if the previous value was different from the other two. But if it's the same, then this should not change. Ta-da! See, me trying to add it didn't change that 0 because I stopped it from rendering. So, so that's how you can tell that this is actually happening, because these two values, I want it's the opposite of what I did before, basically. That's why you would use this ShouldRender. You would use ShouldRender to help you optimize your components better and to ensure that whatever you're rendering does not get re-rendered a bunch of times if you don't want to. So I think that is all the cases that I can show you here. You already saw the OnInitialize. That's pretty simple. I was using it here to render just 1. You already saw the OnParameterSet when I had the other component there by passing the parameters into it. OnAfterRender happens after the fact in theory, but sometimes your component renders stuff that you don't even think about that's happening. It's rendering. So there are some complexities when it comes to the OnAfterRender, but you would use the OnAfterRender to ensure that whatever you're trying to render is already on screen, so you could attach whatever third-party stuff you want to add to it. And then you saw me use the StateHasChanged in order to increment the timer, and then the ShouldRender allows me to control whether or not I want to render something on screen for optimization purposes. That's really it. So lifecycle components can get complicated, especially when you have a case like apparently I have, where you're rendering things that you can't really, it's hard to keep track of. But the rule of thumb is that if you want, the OnAfterRender does one thing really well, the OnInitialize does one thing really well, and OnParameterSet does one thing really well. If you need to change the parameters or whatever, ShouldRender is used if you need to control when you want to render something. And StateHasChanged is used for things like timers and active user count and stuff that you don't have a user input for, but you need to render things. And I think that's it. I think that this example hopefully cleared some things up. I did go over this a little bit more in depth in my other video, and if this was confusing, then maybe you should watch that video as well, and then the two things will go together. But in this case, we saw a far more realistic example than what you'll probably find out there when it comes to dealing with components and their life cycles, because you will run into these problems yourself. Now, how will this affect you on a real project? I'm not really sure, because this is not technically a real project, but this can actually happen. As for my real project that will be coming out, well, you're gonna have to wait for that. It'll take a while to do. Anyways, thank you for watching. This was my lifecycle component tutorial, and I wish you all luck. I'll see you next time. Peace.